Hello, everyone. Welcome to this virtual field talk. My name is Sharon Bowen. I'm the Director of Interpretation and Evaluation here at the Maryland Zoo in Baltimore. We would really like to thank SC&H Group, who has sponsored this field talk series, and they have made it possible for us to open this experience to everyone who wants to participate. Before we welcome our speaker, just a few housekeeping items. We're going to be here together for about 60 minutes in total. My colleague Anthony is running technology. He'll be reaching out through the chat feature with additional information throughout the talk. Your microphone and your video will remain off, but we do encourage you to submit questions for our speaker through the Q&A feature. We will attempt to get to as many questions as possible. We can't guarantee we can get to every question, but we will do our best. You can feel free to submit your questions all throughout the talk, and then at the end, after our speakers finish talking, we will go through those questions. So today we are very pleased to highlight work that's being done by our friends at Cincinnati Zoo and Botanical Gardens. And we are absolutely delighted to be talking with Dr. Lindsey Vansandt. She is the director of the Imperiled Cat Signature Project at the Center for Conservation and Research of Endangered Wildlife, or CREW, at the Cincinnati Zoo and Botanical Gardens. After graduating from the University of Missouri's School of Veterinary Medicine, Dr. Vansandt spent a year at the St. Louis Zoo performing a research internship. She then obtained a PhD in animal sciences at the University of Maryland in collaboration with the Smithsonian Conservation Biology Institute, studying spermatogonial stem cells and their applications in wildlife conservation. Dr. Vansandt joined CREW in the fall of 2014, and her research focuses on two main areas: applying assisted reproductive technologies for the propagation of wild felids and improving the health and welfare of free-roaming cats, including the development of non-surgical cerulins. She has produced the first sand cat kittens and jaguar cub ever born from artificial insemination, and currently serves as the reproductive advisor for the sand cat, jaguar, and Amur leopard species survival plans. Dr. Vansandt sits on the Michelson Prize and Grants in Reproductive Biology Program Scientific Advisory Board and the Association of Zoos and Aquariums Reproductive Management Center Advisory Board. Additionally, she's the medical director of a nonprofit small animal veterinary clinic that provides low-cost wellness services to low-income families. Amazing stuff. Now, we will invite you to join in the conversation again by submitting your own questions for Dr. Vansandt using the Q&A feature. I'll now switch things over to our speaker, Dr. Lindsey Vansandt. Thank you so much for joining us for the Zoo's virtual Field Talk series.
Yeah, Sharon, thank you for that intro. Happy to be here. Let me get my screen shared for you guys. Share. All right. Slideshow from the beginning. All right, and then I'm going to switch that. Swap presenter and switch. Okay, I'm going to go ahead and get started then. Okay, so Sharon gave a nice intro. One thing I didn't put in that information I gave them is my title here as well is a theriogenologist. And I find that that's a term nobody ever knows what that means. So we'll start there. So theriogenology is the field of veterinary medicine that it basically encompasses all area of reproduction. We need a special term because human medicine, you might have heard of like an obstetric gynecologist or OBGYN. So that's somebody who specializes in human female reproduction. And similarly, andrology is the study of human male reproduction. And so being veterinarians, we can't simply focus on one gender and just to sort of denote the differences. But what I think is fun about this word is where it comes from. So therion is Greek for beast. Genesis means to create. And then ology is the study of. So you put that all together, and a theriogenologist is literally a beast maker. And so a good place to call home for Beastmaker is a zoo. And so this is home for me, the Cincinnati Zoo. We are the second oldest zoo in the country. Philly Zoo beat us by a year. We were founded in 1875. A few things we're known for is we have the world's fastest cheetah. If you have any concerns about that, take that up with Nat Geo. They are the official holders of these kinds of records. And additionally, we have this little water potato you might be familiar with named Fiona. So while I am a veterinarian and I do work at a zoo, I don't have the job of a traditional zoo veterinarian. So I work here at CREW. Our building is on zoo grounds up in the corner. And again, it stands for the Center for Conservation and Research of Endangered Wildlife. Now, as you may have guessed from the title, we are indeed scientists here at CREW. And so certainly that is part of our focus is performing research. But we also have 4 other areas we focus on. The second being species propagation. Also in situ protection, meaning protecting our species of interest in their natural habitat. Education, and then finally public engagement. So I'm hoping to be able to perform, some of the latter 2 for you all today. So at CREW, our motto is saving species with science. And to that end, we have these 4 large-scale projects called signature projects, and we focus on these to really strategize on our key strengths of our staff and our unique expertise. So here at CREW, not myself, but others also focus on work with polar bears, rhinos, exceptional plants, and then of course cats, which is what we're going to focus on today. Okay, so a little bit about wildcats. There are about 40 non-domestic felid species. Now I say about because it depends on which geneticist on which day you ask. There's a lot of subspecies and differences. Are they a full different species? Are they just a subspecies? And those sorts of questions. So we'll just go with about 40. And although all modern felid species evolved from a common ancestor about 11 million years ago, which in the realm of evolution is a pretty short amount of time, what we've seen is that because they've dispersed these different species all over the globe, they've evolved with all these unique adaptations. And so what we end up with is a really diverse group of animals to live under one taxon. And so we have tigers that can weigh over 400 pounds. And then we have a tigrina, which weighs 4 pounds. And to this point, most people don't realize that most of the world's cat species are actually small in size, weighing less than 50 pounds. And despite the fact the majority of cats are small in size, there hasn't been as much conservation interest in these small cat species. And so for that reason, CREW for a very long time had 5 signature small cat species we focused on, seen here. And even from these pictures, I hope you can appreciate how diverse they are. These cats live anywhere from the Middle East to South Africa. The Pallas cat lives in Mongolia where it's super cold. Fishing cats live in Thailand, ocelots across Latin America. So they live all over the place and they've had to adapt to their unique environments. If you're not familiar with these species, I highly suggest you use Professor Google after this and learn about them. And just to sort of pique your interest, I'm going to introduce you to one of my favorite sand cats that ever lived, Mr. White Cheeks. And here you can hear him barking. So I find that pretty delightful. So despite the fact that there hasn't been a lot of interest in small cats historically, we made a lot of good ground over the years in advancing assisted reproductive technologies. But when I started in 2014, what I noticed was some of the big cats were getting left behind. And so what I told my boss at the time was that we need to go big or go home. And really, we're doing both because we haven't left the small cats behind. They're still a big focus of our program, but instead we just encompassed a lot more cat species. And so you can kind of see a myriad of the wonderful different cat species we work with. Again, just so unique. You look at each one of them and just the morphology differences, the size differences. It's really remarkable. And so despite this diversity, the unfortunate thing that ties these species together is that to some degree, they're all threatened with extinction in the wild. And by and large, their largest threat has been habitat loss and fragmentation. And so that really underscores the importance of us performing effective management in zoos to help safeguard these species from extinction. So I tend to lean on the same jokes over time. And for years, I've used this slide from Top Gun. And then, as the movie gets older, I feel like people are like, I don't know this movie. And then this is probably the only time in the history world I'll say thank you to Tom Cruise for making a new Top Gun so that this becomes relevant again. But in the original movie, Tom and his friend would always say, I feel the need for speed. And so they weren't so far off. But here in zoos, we have the need for breed. So again, circling back to the Beastmaker, such an important part of my work is just making sure we keep producing more of these adorable babies. And so for that reason, that's why a lot of the work we do at CREW is focused on reproductive sciences. Three main areas we focus on is gamete biology. So gametes are just a fancy word to say the sperm and the eggs. And so how do we collect these samples? How do we freeze them? How do we keep them viable? We also do a lot of work with endocrinology. So that is hormones. And so when we look at these hormone profiles of these different cats, we can start to elucidate the differences in reproductive physiology. And then we can put all that information together and start developing these assisted reproductive technologies. That's kind of a big word, and so we tend to always use the acronym ART. And so again, just as a reminder, not this kind of art in cats, but assisted reproductive technology. So if I just say ART, that's what we're talking about. And so what does ART do for felids? Well, it can help us address incompatibilities between our breeding pairs. So when we're thinking about which cat to pair with which other cat, we're looking at it from a genetic standpoint. Which cats are the most unrelated, which are the most valuable genetically, who's underrepresented. And so when we put these cats together, we really hope the pairing looks like this. But anybody watching, if you have cats at home, you're well aware that cats have opinions. And these cats are no different. Only the difference is that they have claws and teeth. Well, so do your domestic cats, but these guys are a little bit bigger. So sometimes it might look more like this. And so we don't want to keep trying to put these pairs together. It is rare, but sometimes these pairings can cause deadly consequences. And so if we have a pair, even if they're genetically valuable, we don't want to try to put them together if they're not going to get along. And so we can do things like collect sperm from the male and then put it into the reproductive tract of the female so we can produce offspring without these cats ever having to physically interact with each other. Sometimes these incompatibilities can be a physical incompatibility. So this is Britannia. She's one of our fishing cats that we've had here at Cincinnati Zoo. She had a leg injury, so her front leg had to be amputated. So even though there's nothing stopping her from being a great mom, she physically cannot stand for breeding with a male, so she would be a great candidate for artificial insemination. Another important role of art in felids is preserving genetic diversity. A lot of the work I do is traveling to different zoos while cats are having their annual exams, and I can collect sperm from them, or if it's a female, we can collect eggs. Now, in the case of the female, what we'll often do is collect sperm from a male, eggs from a female, put it together in a petri dish, and you've probably heard this term in vitro fertilization or IVF. And so if that fertilizes, then it produces an embryo we can freeze. And so CL, she is one of our ocelots. She was a product of just that. Collected sperm from dad, collected eggs from mom, put them together in a dish, produced an embryo, and then froze those embryos. And so she is standing on the very tank she lived in when she was an embryo. And it illustrates a really good point. Within this tank, there are thousands, if not millions, of potential ocelots. And that is virtually the same size as one ocelot. So as we as zoos get better and better at husbandry, we start thinking about what do these cats need to thrive? We want to give them more space. But all of our zoos only have so much space, and there's so many species we want to conserve. And so if we don't have enough holding spaces, we don't have enough habitats for these cats, we can freeze their genetics, and we're not going to lose those genetics long term. Another role we can do is actually connecting regional populations. So often is the case, there's a male at one zoo that's a really good pair for a female at another zoo. But as much as we joke that cats love boxes, right, the transport of a cat is not that simple. And so what could be easier is simply collecting sperm from that male, freezing it, and then bringing it to that other zoo and doing an artificial insemination rather than having to move animals around. And finally, not just thinking about linking our zoos, but actually linking our wild populations to our zoo populations. So I'll use the example here of a Pallas cat. Pallas cats, our population in our AZA zoos is very small number of cats, and it was founded with not that many individuals, so we don't have a lot of genetic diversity. Now, historically, if I wanted more genetic diversity in this population, what would I do? I would have to go to Mongolia and trap one of these beautiful cats and bring them back here. And so we don't do that anymore, right? We know zoos all started once upon a time that way, but now the only reason we would bring more animals into a zoo is if there's nowhere else for them to go, if they're injured, if they're too young to take care of themselves, but otherwise we wouldn't do that. And so now what we can do is, instead of simply catching this cat and making him come to a new home, we can simply collect his sperm, bring the sperm back, and then off he goes back to his majestic life in Mongolia. And so that's an example of how wild populations can help our zoos, but it can go both ways. And so for this example, I'm going to talk about one of my favorite species, the Amur leopards. And in fact, I'm showing you one of my favorite cats. This is Miss Sophia from the Maryland Zoo. And so Amur leopards are a critically endangered subspecies of leopard, and they're the rarest cat on the planet. They once roamed across Southeast Russia, the Korean Peninsula, and Northeast China, but their range was dramatically, let me show you a picture of one in the wild, but their range was dramatically reduced due to habitat loss, but also losing their prey base and poaching. It's a good story because conservation efforts start to help rebound this population. By the 90s, there was maybe 25 individuals left in the wild, and that was it. Now, thanks to these efforts, we think there's probably closer to about 80 individuals in the wild, but as you can appreciate, that's still a pretty low number. So compared to in zoos in our AZA population, we have about 80 individuals. But this population is actually managed globally. So we don't just work with our zoos here, zoos in Europe, zoos all over the world also hold these species, and there's about 200 animals. What's also nice is these animals in our zoos have more genetic diversity than the wild population. And in fact, there are reintroduction efforts underway to help take zoo animals and have their offspring be re-released back into the wild. So I'd like to take the rest of the time to talk about a specific art technology that we have, artificial insemination. And so again, I'll probably shorten it to AI, not artificial intelligence, which we hear all about in the news, but artificial insemination. So the way we've typically done these AIs in cats is called laparoscopic uterine AI. And I know that's a lot, but we're gonna unpack that. So prepare to get a nice lesson in veterinary medicine and in science. All right, we'll start with the easy one, uterus. So this is a schematic of the reproductive tract of a female cat. And typically when we're depositing the sperm into her tract, it's been here in the uterine horns. So the second term here, laparoscopic, is how we actually do these surgeries. And so if you have a dog or cat that you've taken to the vet to get spayed, you know that they get an incision here on their midline. So you can imagine, especially as cats get bigger, I don't have an e-collar that, readily fits a tiger. So we don't like to make very big holes in our cats. So with laparoscopy, what we can do is make these tiny little keyhole incisions. So to do this, we make one small incision, 5 to 10 millimeters. And with that, we can insert a scope so we can visualize the inside of her abdomen. We then make a small 5 millimeter incision. And with that, we can put a little accessory port, and that allows us to insert instruments to then go in and move around the organs as we need to get this procedure done and see everything. So I can either then just look inside the female with the scope itself, or more often what we do is we have a wonderful assistant who attaches a camera, and so then we can visualize everything on a screen, and we have both hands to actually do everything we need to get done. Okay, so I'm going to warn you guys, there's going to be a video here. So if looking at the inside of a cat is not your jam, look away. I'll let you know when it's over. But what we're going to look at is how these AIs work. So imagine here, the cat is on her back, the tail is behind your monitor, and the head is towards you. And so her belly button is up. So we just go through that abdomen with an IV catheter, and then you basically go inside the uterus, much like a large vein. And from there, we can then deposit the sperm. Okay, the video is over for those of you who don't want to see. And so using this technique, and I will tell you, this is a royal we. This is not just here at CREW, but all the researchers around the world working together. There have been live offspring produced in 11 species of cat using this. By far and away, the two winners, if we want to call them that, have been cheetahs and ocelots. And so with cheetahs, this has largely been done by Smithsonian. They're another wonderful research institution doing a lot of great work. And so this is one of their flagship species. Again, we've done a lot of work with ocelots. So it depends on how we approached it, how we did the study. But in general, we've had success anywhere from 25 to 40% in these species. Now, the unfortunate thing is we've not had as much success in the other cats. So for the rest of them, it's oftentimes been a one-time event. So one time someone did an AI and got it to work, and we haven't been able to replicate that. Another challenge is this is just using fresh sperm, freshly collected from the male and put into the female. Oftentimes, what we want to do is freeze the sperm because the male may be at another institution. So cat sperm is very sensitive, and it doesn't like being frozen. And so the quality goes way down once we freeze it and then thaw it. And so using frozen thawed sperm, again, with the royal we, not just here at CREW, but all of us working together, there's only been 5 successful pregnancies with frozen thawed sperm and wildcats. And so 3 of those have been cheetahs, 1 of those has been an ocelot, and 1 of those has been this little sneaker, a leopard cat. And so if we're not able to, such a big goal of ours is banking the sperm to preserve the genetics, but if we can't make offspring reliably with AI, we're literally just grasping at straws. So I know you guys are all muted, but that was a joke because straws are what we freeze the semen in. So, it brings home this point that it's something that we really need to be able to do reliably to preserve the genetics of these cats. So do not concern yourselves. Science is here to help. And so what I'm going to do is take you through our research program and kind of how we've worked through a lot of these problems. So the thing I'm going to mention first is that these studies have been done in domestic cats to begin with. Domestic cats make a really good model for wild felids because they're also closely related. As I mentioned before, they all evolved from a common ancestor. And so we start these studies first in the domestic cat, which we have more readily access to and can be a little more rigorous in our science. So the first step was developing a new way to do AIs. So again, there's that reproductive tract of a cat. And this is going to sound really obvious as I say it out loud, but the further the sperm starts from where the eggs are, which is the ovaries, the further that sperm has to travel, the more sperm we need to be successful. So if we're going to do a uterine AI, we need about 20 million swimmers. And to be more reliable, to have more chance of success, more likely 100 million. And of course, we're not always going to get those numbers, especially in our small cats. We may only get a couple million. But our theory was if we put the sperm as close as possible, basically into the oviduct where those eggs are going, we should have better success. So graphic picture. So this is a domestic cat using that same laparoscopic approach. So I'm just going to take you through some quick anatomy so it makes sense. All right, so the ovary here in the picture is this structure here. The uterine horn, seen in this picture kind of coming downwards, is that tubular structure. The oviduct, which is the same thing as a fallopian tube in humans, that is the structure you can see here on this picture, and then it's snaking around to connect to the uterine horn there. And then the fimbria, the fingers, basically the funnel-like opening here, is what those graspers are holding on to. And so inside of that is that opening, and so that's where the eggs go naturally. And so here on the picture, that is where that needle is going into. And I do want to point this out too, that needle, it's not a sharp needle, it's blunt. It's going into the natural opening, and that's where the sperm is located. Okay, so just to show you another picture, this is what those fimbria actually look like opened up. And then again, that's that opening. So the picture is a little bit kind. The actual opening is quite tiny. So the picture always make, oh, it's really easy, but actually finding that opening can be challenging. And then just to, again, kind of take it full circle, that's the oviduct in this picture. Okay, so we're going to show you a video. So on the left is going to be that picture before. On the right is going to be a video. And again, the cat is on her back. The tail is behind your screen. The head is towards you. And then the belly button is up. So here you can see the needle is going in and finding that natural opening, holding onto those fimbria or fingers, and then someone on the outside is going to push air through that needle, and that's how the sperm gets where it needs to go. So what we found was that we did not need a lot of sperm for success. As I mentioned before, we needed 20 million, 100 million. We needed 1 million to make this approach work. The other exciting thing is the pregnancy rates were really high, 56%. So that's kind of step one. So the next step is how do we actually prepare the female? One of the biggest challenges we face with doing artificial insemination is actually getting that female in the right stage of her estrous cycle. So this may look familiar. This is sort of Repro 101. These are all the hormones that kind of come into play as a female cycles. And so follicle stimulating hormone, or FSH, its job is to basically make that egg get mature, tell that follicle to grow and get that egg to be mature. Luteinizing hormone is what is actually responsible for that egg to ovulate. And so we need something that acts like those hormones in the female. And so I'll tell you the full names once just for fun. You don't have to remember this, but equine chorionic gonadotropin, or ECG, acts like FSH, and that's why it's color-coded to be the same. And then human chorionic gonadotropin, or HCG, acts like LH. Couple problems. They have really long half-lives, meaning they stick around in the cat for a very long time. And the challenge is it keeps stimulating that ovary. And so there's a possibility that it does become a challenge, and this has been demonstrated in humans as well, that ovaries can get hyperstimulated, and that's not a good environment to nurture fertilization. The other issue is these are very large. The cat's immune system can recognize it. So we haven't seen anything like anaphylaxis. The cat doesn't get sick, but she can mount an antibody response to the ECG and HCG. We're basically vaccinating her against these hormones, meaning we can't treat her again 6 months, a year down the road and try again. A big breakthrough for us was finding a newer version of LH derived from pigs, or porcine LH, and it's smaller and it has a shorter half-life. And what we found is it's very consistent in inducing ovulation in these females. So that was step 2. Part of the hormone treatment protocol is that even getting the female ready to ovulate, we need a very quiet, inactive ovary. And so our friends at Smithsonian came up with this solution using this drug. It's called Regumate. So it's in essence the same thing as human birth control. It's a synthetic form of progesterone, so the hormone that is secreted when a female is pregnant. So what that does is it just quiets out the reproductive tract. And the nice thing is it's something we can just feed the cats every day. So we can just give it to them every day in their normal food, and then just stop giving it before we do the hormone treatments. And so we put that together. We put down giving that oral progestin treatment along with those hormones and performed artificial inseminations. It was a small study, but 86% of the cats got pregnant, or 6 out of 7. And so then the next step, of course, is getting this to work with frozen sperm. And I'm already put way too much into this talk. So I'm not going to go too much in this, just to say that we came up with a new way to freeze sperm with a new freezing media. So what this graph is showing is the success of AI doing these artificial inseminations either with fresh sperm, which is in blue, or frozen in red. Now, had we done this with any of the other ways we used to freeze sperm, what you would see is that blue bar is going to be where it is. It's pretty high. Oviductal AI is great, but that red would be near the bottom. And so with this new freezing technique, we are seeing success in frozen sperm that approaches fresh sperm. And that is a real game changer for us. So that's the work in the domestic cats. Of course, now the goal is applying this to our wild cats. So what I'm showing you here is all of the species we have now had success producing babies using this laparoscopic oviductal AI technique. The clouded leopard seen there on the top, that is actually the work of Smithsonian. They came here and trained with us. You can tell we're very collaborative. So that they have taken that technique back with their team, and they're now having success. The tiger, I like to point out, that was an AI performed with 150,000 sperm. That's all we got from the male that day. That's it. And successful pregnancy. I will throw this little leopard cat again, not our work, but another group who read our research. We try to publish and have everything out there for everyone to use. So they took all of our techniques and had success in the leopard cat. Okay, another graphic video. You'll notice that Amur leopards are not on this list. It is a species we are still working on. But I wanted to show you, this was Maryland Zoo, as I mentioned, great collaborator for ours. We actually performed this oviductal artificial insemination with them, with their female, a few years ago, several years ago. But in case you ever wanted to see the inside of a leopard, here you go. But again, same setup. So the ovary is that big structure. The red you see are actually ovulations. So the hormone treatment protocol worked. We were using frozen sperm, and unfortunately she did not get pregnant. But we still learned a lot from that procedure, and we're getting there. So hopefully in the news in the not too, distant future, you might hear about our first success with Amur leopards. This shows you all of the females, or all of the species rather, that we've had success using frozen sperm. So anybody with a snowflake is a species we've had success using frozen sperm, which is fantastic when you think about our rates before. I'm going to end now with just a few sort of conservation stories. We've done a lot of science, so I want to kind of talk about what we're doing moving forward. Okay, so let's talk about the ocelot. So ocelots were once heavily hunted. It was all the rage back in the day to have an ocelot fur coat. People liked them as pets. This is a very famous picture with Salvador Dali. If anything, I think this ocelot is a poster child why not to have ocelots or any wildcat as a pet. And it got so bad that in the 1980s, they were listed as endangered. But thanks to the Endangered Species Act, they have really rebounded, and now they're listed as least concern. Having said that, they still have a lot of challenges with habitat, having enough habitat, and so their numbers are still declining again. They are native to Latin America, but they also are here in the US. A lot of people don't realize that. They once ranged across much of the Southwest, However, now their habitat has shrunk to Texas. What you're seeing in green is their historic ranges up to 1990, but since then it's gone vastly down, and that little red dot is where they live now. They basically have two populations. One is on a private ranch. The second is at a wildlife refuge, only totaling 60 ocelots. Versus we have 100 in our zoos. And so I mentioned this before, we have had a lot of success with ocelots. So this is, all of these pictures are females that were born from artificial insemination. And what is along the bottom is all of the offspring. These females have then gone on to reproduce on their own using natural breeding. And we've had so much success that now 40% of our Brazilian ocelots in our zoos were derived either directly or indirectly from artificial insemination. And so that's definitely a check in the win column and part of the impetus for this project. So now there's a big project called our Texas Ocelot Recovery Program. So we are collaborating with U.S. Fish and Wildlife Services, Texas A&M, as well as the East Foundation, which is a group of private ranchers. And it's, you know, it's so rare to hear about the government, especially in Texas, ranchers and the government working together. But everyone's really jazzed about these cats and trying to save them. So who I'm going to show you here is Dr. Ashley Reeves. So she is a veterinarian. She actually came and trained with us at CREW on these techniques. She is now working with Fish and Wildlife. So they already had a program, a health surveillance program for these ocelots. They will trap them, anesthetize them, do full physicals, do blood work. So at that same time, she's able to bank sperm from these males. She's then taking that sperm and performing artificial inseminations in zoos, helping to bring new genetics to our zoo population. But this program is working both ways. And so right now, construction is underway to build what's called the Ocelot Captive Breeding and Rewilding Facilities. So what the plan is to take some of our cats from zoos, move them to these facilities, have them breed, and then re-release the offspring back into the wild. So stay tuned. This program is still pretty new. The facility should be built next year. So again, hopefully here's some good news in the future there. And I'll end with the jaguar. Okay, so the jaguar is another one of those cats near and dear to my heart. They are the largest cat native to the Americas and the only member of Panthera that we have on this continent. So they're classified as near threatened. There's probably about 40 to 50,000, but the problem is their habitat is highly fragmented. The most robust populations we see in the Amazon and the Pantanal, but again, very fragmented populations. They can't move genetics around. And so that's where art could really help move the genetics and maintain the diversity of these populations. However, we did not know a lot reproductively about this species. And when I started, there had never been a successful AI. And so that was the impetus for this project. We have a wonderful group we work with in Brazil called Mata Ciliar. And so I've been traveling down there when I first started here, probably once or twice a year, working with them and their cats, trying to get this to work. So everything we just talked about is what we had to do starting over in the jaguar. So of course, we already had this oviductal AI approach, but at the time we hadn't done a lot of larger cats. And so you can imagine you come up with this technique in a cat, a small cat, there are always challenges. So we have to tilt the females during the surgery. It kind of helps get like the GI organs out of the way. And jaguars are a chunky cat. And one of the first days they had a tilt table and we broke the tilt table. So if you can tell in that upper left picture, what's happening is we used my shipping crate that I bring supplies in, and then we had the cat tied to that, and then basically had her elevated, and then a very eager vet student was the one holding that all together. You can also notice as I'm leaning forward, look at that bottom left picture, that's what I'm leaning up against. So luckily they have a great vet staff there and I felt very safe, but it is a little treacherous leaning against that mouth. And then you can kind of appreciate just having to work from the side of the cat. I'll say this though, it's not as bad as tigers. So this is some of the tigers we've done. This zoo on the upper left, they have a window so the public can see what they're doing. And this poor girl was very concerned about what was happening here. And then on the bottom, this was actually the Columbus Zoo when they have the Secrets of the Zoo show. And so this was an Almer tiger. She was over 400 pounds. You can see the wooden ramp they built for us. But she was so big, she was not staying on the ramp. So all of the people you see kneeling, the maintenance team who built this ramp was really excited to see it in action, had to then stand around and hold this cat up for me. And most of the surgery, this was me leaning over her paw with, again, one of the maintenance guys right next to me. So it can be a little difficult to do this in larger cats, but we can get it done. another video. So now you can cross seeing a jaguar inside of the top of your list. Same thing, set up as before, tail behind, head towards us, only now we're on the other side of her reproductive tract. What you're seeing in that ovary, I know it looks really bloody, those are all ovulations. So those were all very fresh ovulations. That is what it's supposed to look like. And then again, you can see the blunt needle finding its way to that tiny little hole into the oviduct, depositing the sperm. This next video, I believe, has sound, but we've seen the inside of the jaguar, we've seen the inside of an Amur leopard, but seeing what this procedure looks like on the outside, so I'll play that. She's almost there. You can hear them saying she's almost there. I've been almost there for probably 10 minutes at this point. It can be very lonely being the person doing the surgery with all these people watching you. And then there is Dr. Bill Swanson. He is pushing the sperm into the oviduct.
It went fast.
So that's what that looks like. And so the only difference is we were doing these with fresh sperm. Again, it's easier with fresh than frozen, so we've not had success. But this was about 5 different iterations of going through all of this, optimizing everything, getting there to this end. So you're looking at the first jaguar cub ever produced from artificial insemination. So that was a huge win for us. I'll point this out too, just probably the level of difficulty of getting there. All of the other big cat species had success with AI. This was the holdout, which if you know anything about jaguars, checks out. They're a very complicated cat. And so I love this story because it really highlights how a systematic research strategy can get us there. We're not going to do it right away, but we read what we've done and we can pivot and, take the evidence and move forward. And again, having this work really invigorates that possibility of using art as a management tool in the species. So for summary, most of our world's cat populations are declining. And that really drives home the point that our zoo populations are so important to serve as an assurance population and a hedge against extinction. Art is really critical to ensure that our zoo populations remain viable, and we need science to be able to use these because each species is a little bit different. I want to give a shout out to my wonderful team here at CREW. I mentioned all the domestic cat studies. We actually have a colony of domestic cats here. I also point out that we always adopt them at the end. So if you're ever in Cincinnati and need a cat, come my way. They make great pets. I have 3 of them at home. And that is it. So thank you, everyone. I'm going to go ahead and stop sharing.
All right, great. That was amazing. We actually have our adult summer camp happening right now, and they are logged on and watching. We have 2 veterinarians in that session, so I hope that they are currently watching and enjoying this. I'm sure they are fascinated by it, as we all are. Amazing stuff. So just a couple things that we have some questions coming in, and just some things that I was thinking about, and some of my colleagues here in the room were wondering about. So you had mentioned specifically work with Smithsonian, and you highlighted some other collaborations, and you mentioned how that important collaboration is. We get a lot of times from our visitors the idea that, oh, well, zoos are competing against each other all the time. Could you speak more to the importance of collaboration in this kind of work, in this kind of field, and give us maybe some more examples of important collaborations that have really supported your
Oh my gosh, absolutely. Yeah. So I in general, I'm very proud of our Field Taxon Advisory Group. That's like all of the sort of advisors from veterinary, nutritionists, keepers, researchers. It's a very active tag. What we say, we love everything we do, we shorten words, right? So tag, but we all work together to kind of come up with these plans for these species. But we have a meeting, like we hold a meeting together every year. We actually put together courses to help keepers just, learn how to take care of these cats. We have an advanced course this year. We're teaching reproduction. So everybody just wants to share and have ideas and like, how do we help each other? Because we're all towards the same goal. And to be honest, there aren't that much of us, and we don't tend to publish all the time. And like, we're not the top news story at all, all the time. So it's not about the glory for us. It's just about getting the work done. And so yeah, we have a great long-standing collaboration with Smithsonian. I actually, when I did my PhD, it was with Smithsonian. My boss, Bill Swanson, was also at Smithsonian. So we're a bit of an incestuous group there. So we work wonderfully with that team. The Omaha Zoo is another great research facility. So actually we are finishing up a grant with them. So while jaguars and armor leopards are sort of two of my flagship species, tigers and snow leopards are two there. Dr. Jason Herrick is, I forget his position now. He was the director of reproductive sciences. He's now super high up, but we put this grant together to kind of teach each other what we're doing, come up with different techniques and all work together. So, yeah, I mean, we work with collaborators around the world. We're not, I am competitive on certain things. I give blood and I want to see how fast I can give, but for whatever reason in science, we're just trying to help each other, and we're always on the phone with each other. Like, what did you do? How did you do this? What do you do this? Because we're just a small but mighty group. So yeah, collaboration is key.
Yeah, I mean, conservation is so complex, and
Yeah. And I'll say that too.
Do it alone.
Yeah, and all the zoos we work with, working with you guys, like just being willing to do these being willing to try this, knowing, we're still figuring it out. We don't exactly have the answer. We know how to keep the cats safe while we're trying, but we don't have the answer. So all these facilities we work with are so key because, we only have so many cats at this zoo, or, each of our home zoos only have so many animals. So it's really wonderful to have such a good community to work with that's so engaged too.
So one of our viewers is asking, could you tell us a little bit more about your cutting edge work with the domestic cat population?
Yes, I would love to. So that is a rarity where we actually did get published in Nature for that one, but we're like, it's sort of the other side of what we do, right? So we work on trying to get our wild cats pregnant, but we're concerned with domestic cats. There are 80 million free roaming cats. We don't know the exact number, but about 80 million free roaming cats in the United States. So unowned outdoor cats. And we know they don't have easy lives. And I'm a cat lover, but I'm a wildlife lover too. They are an invasive species, and they wreak havoc on these populations. And historically, trap, neuter, return has been the solution that we can come up with, i.e. catch these cats, neuter them, vaccinate them, kind of get them healthy, and then put them back. Because if you just, let people just kill them all. You can't do that because, one, who wants to do that work? It's going to have to be veterinarians. Most of us don't want to do that. Two, removing these animals, more just come in. And so we really need them there to kind of resource guard. And the problem is trap, neuter, return, it's surgery. You need veterinarians, you need care. How long do we keep them before we put them back? If they're truly feral, they don't want to be under human care, but especially a spay, put it right back. So there's a lot of challenges. It's grassroots. So we've worked with, again, collaborative. Gene therapy is not my area of expertise. We work with a variety of groups. Part of my background is I serve on the Michelson Fan Animal Scientific Advisory Board. That is their goal, is to find a way to do this. And so they encourage people not in this field to get together. So through that collaboration, we work with a group at Harvard, Dr. Pepin leading that, looking at a way to use gene therapy. And so what we found is a single injection, and this works in females, but not males, unfortunately. We cause them to produce a hormone called anti-Mullerian hormone, or AMH. You might have heard of this in humans. They'll test your blood levels as a female. It measures your follicular reserve. So your follicles are sort of secreting these levels of this hormone. If we can overexpress it, have them make a high level, what happens is that hormone is regulating production. And so as follicles grow, they make this hormone. It says, okay, nobody else, it's not your turn. Because whether you're a human or a cat, you don't want to ovulate like 50 eggs at once. So this hormone's doing that. But if they just constantly see this hormone, they won't produce the follicles. And so we've done a study here with CREW with our domestic cats and found a single injection. And the longest study started in 2019. The hormone levels are still at that same level, one injection. And what happens is, even when we put them in a breeding situation, and some of the females will still breed with males, they don't get pregnant. They do not get pregnant, and we're now 5 years out, and those hormone levels have maintained. So we're still working on refining that technique, finding the most efficient dose, how to make it cost effective. And there's a lot of safety studies we need to do still just before deploying it. Again, not my expertise, but that's the beauty of collaboration. The Michelson group has people on the regulatory side. So they're talking with the FDA. They have a whole arm for veterinary medicine. What studies do we need to do? What do you need us to do to sort of get it there, to get to an endpoint of a product that could be commercially available for people doing this work?
So then we're still a bit away from commercial
Yes,
viability.
unfortunately. And it's so funny because we get after, like, especially after it first came out. So that is one of those, okay, we did get some news stories about this one. We've had a lot of phone calls at the zoo asking people with, oh, I've got feral cats, can you come help? And I'm like, I would love to, but not yet. But the good news is we have a wonderful community here. The Joni Bernard Foundation actually funds part of our work. They're local, so they do a lot of great work funding these. And there's a lot of great local shelters who are doing the trap neuter return right now, which is the best option we have right now. So we at least have somewhere to send them, but yeah, it'll still be years away, but that's a good thing because we want to make sure it's safe before we do it. So it's a good thing. It'll take a while, but it is painfully slow to do this the right way.
We'll all stay tuned and be excited for, that continuing to progress, because that's amazing work. We had someone asking, how did the Endangered Species Act actually help ocelots recover? But what technically did it allow to happen? Did it lead to bans on specific products, or what?
Yeah. So basically illegal. There are actually people who still contact the zoo who are like, I'm so sorry, my grandma has an ocelot coat. I don't know what to do with it. But yeah, just giving protection. They just weren't protected. There was no laws. There was no repercussion. There was nothing stopping it. And I think there's a public education piece of that as well, of just people understanding this is a problem. I think we have a long way to go with a lot of these laws we have, but it's a slow process to kind of get us there. But yeah, I just generally and it wasn't, even though the Endangered Species Act was the US, like there were reverberations in all these other countries that ocelots are in to really help and say, okay, this is a problem and we need to step up and stop it.
Someone has asked, were there any issues with the mothers who have gone through the AI process, not being able to care for their young, or their natural behaviors didn't take over? Was that something that came up through the AI?
That's a great question. No, I will tell you in general, cats can be challenging. We do have a lot of issues with cats in our zoos, and we see it in the wild too, not taking good care of their offspring, whether it's AI or natural. But by and large, it depends on the species. Ocelots are one. Again, they're our golden child. They do really great. And it, because they're still getting the same exact hormones. They're still going through everything naturally. Their body is experiencing everything. So things like oxytocin, you think about, that's like the trust hormone or the love hormone, like all of those things still happen normally, irrespective of sort of how we got there.
Okay. Someone's asking, what are the challenges, particularly with Amur leopard AI?
I think part of it is a numbers game. Again, when I started, we were so focused on small cats, and that was one of the large cats that I wanted to start with. I think Sophia might have been the second or third one we even attempted. And so a lot of times we were doing this at zoos that don't have a male. So frozen, again, adds that challenging. It'd be nice to start with fresh semen. And then of course, COVID happened and slowed everything down for us.
Sure. Yeah.
The Jaguar success was in 2019. That same year, we also had a couple frozen sperm AIs with ocelots that were exciting, including sperm from a male that had died and had never reproduced. So we had a lot of wins, and we were really excited about everything we were going to do. And then COVID happened, and stopped it all for a while. And it's just kind of getting back into the swing of things. Like Grant, I mentioned, we have been doing some artificial inseminations again, but I think part of it is being smart about picking the right candidates. Sometimes we tend to focus on older females who haven't bred before, and as females age, just like humans, that sort of, it's like frozen sperm makes it hard, age makes it hard. But the tendency is to put the young ones together because we want them to produce offspring, and then I get called with these sort of older females that are very valuable but have not been in a breeding situation for whatever reason. So I think that's part of it. But as a species, they respond really well to the hormone treatments, and they actually have a pretty easy sized oviduct. Jaguars, like everything else about them, their anatomy is really difficult. Amur leopards are really easy to do the inseminations, and they're not such a big cat where it's challenging. So they have everything in their favor. I think it's just for us a numbers game of just having the opportunity to do a few more, and I think we'll get there.
Have you had any challenges with females that have been contracepted in having success with AI? Or has that come up?
That has been a challenge for us, because for a while, that was we thought, oh yeah, we'll use these things and they'll reverse, but with time we learned that some females took a lot longer to reverse than others. we have had challenges, although I'll tell you, sometimes we call ourselves good luck Chuck. We'll come with a female that has been contracepted, hasn't been doing great on her own. We'll attempt an AI. If we're not successful, sometimes she cycles back and gets back with the male and breeds on her own and then has offspring. So sometimes I think the hormone treatment protocols can help with that. And so even if the AI wasn't successful, it seems like it sort of resets her. And then we can have success with natural breeding. So we're happy however it happens, you know?
Sure, and that's a great case for, basic science research and
Right.
how everything that we learn from the work that we do can be applicable elsewhere.
Mhm.
All right, let's see. I think you did answer this in your presentation, but maybe if you can just remind us, what are the 9 species that AI has been successful with to
Oh
date?
no.
She
Oh
did not.
gosh. You're gonna really challenge me. That's like on the pressure. Okay. All right. So we have the easy ones. So we have, tiger. I'm trying to go through my list. Oh my gosh. I should have written this one down.
Do you want to reshare your slide?
I don't think I have the
Like you
species
had a
on
slide.
there.
Oh,
I'm trying to think. The first success ever was actually a puma. So I can tell you puma. Let's count these out. So lion, tiger, wasn't a jaguar at the time. Oh my gosh. Cheetah, ocelot. Let's keep going. Leopard cat. Black-footed cat, not a fishy cat. I'm terrible, you guys. You got me. You got me. I know.
you know what? That's
And it was, I will say
That's
this, it
fun.
hasn't been an Amur leopard, but a Persian leopard. It was actually here at CREW long before my time. A Persian leopard is on the, so leopards are on the list as well. It was a Persian leopard here. Very, very early, might have been the first or second successful AI ever. Let's see. We're almost there on numbers. I'm trying to think. Probably clouded leopards. Yes, clouded leopards because they're a big cat too. This is gonna be so embarrassing later when I watch this. I'm gonna be like, oh, it's okay.
Oh, it's amazing to think of all that you've done. So that's
And it's not just, again, that is the royal we. That is
sure.
yes.
Yeah.
That is the royal we at CREW, that's a royal we with everybody. So I always want to make sure I'm not like done 11 species. No, it's a royal we.
Someone's asking, is there any research or information sharing exchanged with human IVF doctors?
We do actually work with them. CREW has had a long history. A lot of the earlier procedures, we have a big University of Cincinnati next door, and they have a whole, I'm not sure what they call it. I don't think OBGYN Reproductive Sciences Center as well. So historically we have worked with them. And I know a lot of zoos, even, especially with primates, will call in like an OBGYN to help with a C-section or something like that. But we are actually, I just presented on the non-surgical work with their group, and we're trying to get together with a meeting to kind of talk about, again, kind of rekindle that relationship and think about it. But for sure, I think we have a lot to learn from human medicine. Another species, unlike, a lot of the reproductive work in animals is in food animals where we breed them for reproductive success. So they're sort of bred for their fertility versus, humans, same kind of like cats. We're trying to breed the ones that are having trouble breeding. And so I think there's a lot of good lessons there that we can learn. So we definitely read the human literature and consult with people, and there's a lot of useful information for humans as well. Although I talk to my friends who do assisted reproduction, I'm always like, how does this work in a person? I'm so confused.
So I know we're bumping up against our end time here, but I would love to know myself, this is my question to you, what has been your biggest eureka moment as a researcher doing this work?
Biggest eureka.
Biggest,
Well,
or wow, or just biggest, like, I can't believe that this is what's actually going on.
oh gosh. I'm trying to think. There's been so many. I want to pick one that's like exciting and a good topical story. Wow. Now you've stumped me. I'm still thinking about my 11 cat species.
Oh.
No, it's fine. I think for us, sometimes it's like the simple answers. It's like, oh, why not put the sperm closer? That makes perfect sense. Or honestly, we talked about this hormone treatment protocol, but in humans, to kind of we'll circle kind of everything together here. In humans, a lot of it is natural cycle. Versus with cats, we've historically tried to do where we're giving that first drug that sort of induces those follicles to grow. A natural cycle means the female's follicles are coming in on their own. And for the longest time, the mantra was, you can't really make it work. There's too many species. And we're like, well, we can do this. There's so much monitoring we can do that we don't think we can do. Talking to keepers, like, oh, we can do vaginal cytology. We can train a cat for that. Or just looking at, oh, it might be as simple as just doing body temperature to see when she's in estrus. So sort of these moments of you can't do it that way and then you can. So a lot of our work now, I didn't talk about today, is on natural cycle and just new ways of monitoring when cats are coming into estrus and like, oh, we can do this way. Zoos are willing to do this. So it's sort of you have to remember not to let people tell you sometimes that it can't be done this way and we're not doing it this way. Sometimes you have to take a step back and kind of look at it. Well, actually, that I will give that credit to my associate, Julie Barnes, who's also a veterinarian, who I think when she started as my postdoc, was like, well, why can't we do that? So I'll give that as her eureka moment, or maybe she gave me my eureka moment of like, we can do it that way. So it's that like, stop thinking that it can't be done, because it can be. So I'll give that.
That's great advice. You know, don't be hemmed in by those assumptions.
Yeah, I was going to step back from
the
those
limit.
Yeah.
Yeah, I think that's great. I love that. Let me see. I think that's all the questions that we had from our viewers. Thank you so much. This was absolutely fascinating. Thank you for the work that you do and how you contribute to the zoo community and the wider conservation community. Absolutely amazing. We appreciate your time with us today.
Well, thank you for having me. It was a pleasure.
Oh, so much. And thanks again to our sponsor, SCNH Group, who have helped us to bring this field talk to a wide audience. And thank you to those who have joined us today on this webinar. We hope you'll join us for another field talk. Be sure to check back on the Maryland Zoo website for future opportunities. Everybody have a great afternoon. Thanks.
Bye.